asking some questions in the comments below. I'll just get started. So here's all the physical quantities that are given in the problem. I converted the temperatures from Celsius to Kelvin because for the heat transfer, the units of the heat transfer are in Kelvin, so I want everything else to be in all degrees in Celsius to be in Kelvin to correspond. And another thing to note, that the system is the water in the pan and the surroundings are everything else, and these surroundings are going to be negligible throughout what's going on here. And that's going to be convenient for the next problem. I'll explain why. Question A is asking for the final temperature of the water after a short time interval. And I got the answer by considering that the displacement of energy of the system is going to equal, and these should be thermal energies. The displacement of thermal energy of water, and the same for the pan. And since we're dealing with thermal energies, their formulas pretty much carry over. So the formula for this, corresponding to the water, is the mass of the water times the heat capacity of the water times the displacement of the temperature of the water, the same for the pan. And it's pretty much algebra from here. A few things to note, that the final temperature of the water and the final temperature of the pan are going to be the same thing, because once the water is poured into the pan, or the way I consider it, it's going to be one object with a final temperature. They're going to have the same temperature. So ideally, this is what we're solving for. We just have two of them now, and we want to get that by itself, which is just going to take a little bit of algebra. And since we considered the system to be the pan and the water by itself and everything else is negligible, our displacement of energy is going to be, of thermal energy I guess, the only one we really care about is going to be 0, which is very helpful. And since we set that equal to 0 and did a little bit of algebra here to get to this step here, and it's pretty obvious that I'm solving for this final temperature here and here. So with a little bit of algebra, I get that by itself, and everything else follows. And all these values are on the first page, so you can plug them in, and I get the answer of this in Kelvin, because I converted all Celsius to Kelvin. And to convert back, you just subtract, I think, like 274, and you get your answer in Celsius, which I have here. And that's the answer. Okay, part B is asking for energy transfer, and it gives a few values like work, if I remember correctly. Yeah. And so I found the answer by considering the idea that the displacement of energy of the system is equal to work plus the energy transfer, yeah. The energy transfer, that's a bad looking Q, but whatever. And we want to solve for Q, so subtract W on both sides, and here it is. And with that being said, the displacement of the energy of the system we already said was this, minus the work, and all of this is equal to this over here. Basically following from the thermal energy that we're dealing with, because these are both thermal energy values. And I've kind of denoted them a little bit differently, because we're considering now the initial temperature is when the water in the pan, like that interaction as soon as the water's poured into the pan, that's the initial now. And then after the pan's placed on the hot stove, that's going to be our new temperature. So that's why this initial is going to be the final from our last problem. And the final is going to be after being placed on the hot electric stove. And I'm considering, again, since we're considering the initial now to be the final before, that interaction between the pan and the water is going to have one distinct temperature as opposed to two. So where are we at here? I'm going to consider this difference in temperature and this one to be the same thing. So from here to here, I distributed that difference of temperature, since they're the same, just a little bit of algebra, and they're in Kelvin. So this final one, this initial should look familiar. This final one isn't too bad. just add 274, throw in everything else, and plug it in the calculator, and we get that. Not too bad.